Good morning, superhumans! Have camera, have microphone, I can see I've got levels. It's all good, it's working. Firstly, we've got a few people here already. So, Michael, Jacob, Sion's here, Hans is here. Thanks for coming along. Akim, James. Alright, so, just quickly, before I get into other topics for the day, my shout out for this week is Kinaway Chamber of Commerce, which is a chamber of commerce specifically for businesses owned by Aboriginal and Torres Strait Islander people. So if you're looking for a business that provides services in Melbourne, which is owned by an Aboriginal person, this is a good place to start. So, okay. I've got a few different things to go over today. Little random topics. And it's the usual situation where I think a random topic might go for 10 minutes and it ends up going for 2 hours. So, firstly, g'day to everybody. 1 AM now, not morning. Henrik, okay, so you must be in Europe somewhere, I'm guessing. Alright. So, DJ Moss from Finland. Fantastic. Alright, so where are we? Desktop. Let's jump into here. Can I switch views to desktop? There we go. So what I was going to start with today, at least, I don't know how long this is going to take, but it seemed interesting when I saw it. Oh, what? I just did a search for Arduino Lint, and this queued live stream is the #1 result. What is going on there? Alright, so Arduino Lint. This has come out fairly recently, and it's it's a general topic I had in mind, but I haven't really thought about how I'm going to go about this. So a linting tool, or a linter, is a static analysis tool which looks at source code for your project and tries to discover problems before you run the project. And for projects where you use a compiler, like C, C++, those sorts of compiled languages, the compiler catches lots of things, but a linter is an interesting and useful tool because what it can do is allow you to create policies or rules that are outside of the compiler and discover potential problems with your code before it goes into production. So it's a good part of a continuous integration pipeline. So typical CI/CD systems will involve linters or various other checks. And linters have been around for a very long time, like since the 70s, I think, maybe even earlier. And so I was very interested when I saw that the Arduino team have just released an official Arduino linter called Arduino Lint, and it is presumably because they're using it internally. I don't know, but it came out fairly recently. I think it's a couple of weeks ago that it was announced, and it's a command line tool that you can use to examine your projects and see if it detects any problems with them. So I thought I would install it and try running it, point it at a project and see what it can find. Hopefully it finds things that I've stuffed up. And typically what a linter will do is look for, it could look for things that the compiler is not necessarily going to see as a problem, but which might be indications of issues in your code. For example, maybe you, well, a really basic one is things like indentation and syntax. So if you want to enforce some kind of a consistent syntax or a consistent indentation and those sorts of things within a team of developers, then a linter is a good way of checking whether everybody is using the same thing, because it can check differences between tabs versus spaces for indentation and those sorts of things and say, nope, that doesn't comply with the rules, so these lines get tagged. But it can also do things like I mean, I'm making big generalizations here. This is just talking about static analysis in general. But you could do things like look for a variable that is declared but then never used. And that might be a sign that you've been working on the project and you might be working on a new feature and you add some variables because you want, like you've declared some variables, you're going to use them, but then you don't end up using them and they just end up hanging around in your code as cruft. And then later you might have some kind of a namespace collision because you've got this variable that's been declared as a certain type and then you declare it somewhere else and you've got two declarations. So linters are the sort of thing where you can run it against your code and it will pull out those sorts of problems. And then you discover it before you go to production. So yeah, as I said, very common in commercial software development environments. Sion said, "Don't run it against my projects." I'm going to run. I'm going to run it against my projects. Yeah, Akim said it's Google that serves you what it thinks you would want to see, and try searching in privacy mode instead. That is a great idea. So incognito. In fact, what I'm going to do, even better, I'm going to go to DuckDuckGo. So I'm in incognito mode. I'm using DuckDuckGo, which means that there should be no history or anything of what I've searched. So if I search for Arduino Lint, let's see what comes up. Some ads. Yep, a couple of ads to get started with. So Arduino blog, that's what I would expect. The first result should be the Arduino blog announcing the release, which was on the 13th. So when is it now? 31st. It was a couple of weeks ago. I'm a little bit behind the times. And oh, there's a video about installation. Cool, this is better. There is no reason that a video that didn't exist yet should be the top result. So this is the blog post from when Arduino Lint was released. And let's give it a try. In fact, I'm going to get out of here. So I'm in, oh no, it doesn't matter. Let's just download it. Installation. Let's grab it. And then try running it against maybe something like the air quality sensor project, because that's a reasonably recent one. So we can install it from a script. Okay, so it runs on Linux or Mac OS and on Windows. Cool. Download pre-built binaries. Let's do that. 64-bit Mac OS binary download. Go, go, go. James, hello to Miliwake. Alinta. Yes, Michael, what does Alinta make? Alright, so we've got a tar.gz. Let's pull up a terminal. Oh, except that I'm on a different window so you can't see it. Here we go. Terminal. And let's make it larger. Let's make it mega large text mode. What do we have? John Zip, a blah blah blah. What have we got? Tar, what is it? XF. I could have just done it in one move. I don't know why I didn't do that. Alright, so we've got Arduino Lint and a license file. So we've got a program there. Let's put it somewhere in, that'll be the binary, I assume. Let's see, what directories do I have in my path? Ooh, Python, I've got user local bin, that seems like a good place to put it. MV Arduino Lint into user, come on, I can type good, into user local bin. Alright, so now I should be able to do Arduino, why can't I? Arduino Lint, user local, oh, maybe it's got execute, I don't know. Anyway, if it's in my path, I should be able to execute that. Arduino Lint, it's got execute flag set. Anyway, one of you is probably seeing the problem right now. So let's go into the air quality sensor project, AQS. what have we got here? Firmware, and I've got a couple of different versions of the firmware there. So the one that's been shown so far on the Air Quality Sensor Mini series is this one, Air Quality Sensor D1 Mini, and this is the one that I did the code walkthrough a while ago. Michael said should probably put it in the applications folder. Maybe. Alright, so anyway, I can just call it by user local bin Arduino Lint. Let's just see. I'm just poking around here to see what happens. I need my window to be a bit bigger. It's wrapping. Alright, so Arduino Lint checks for specification compliance and other common problems with Arduino projects. So we can call it with some flags, and lint project in project path or current path. Okay, so I could probably just run it right here. Let's just see what happens. I'll run it with no arguments. Warning count 1. No license file found. Rule SD002 fail. Alright, now, I can see just up the top there. If you look up the top, you can see it's got a verbose flag. Show more information while running rules. So let's do -v. And now it is telling us what rules it's checking. That's not very many rules. I would have thought that it would have far more rules than that. Strange. Okay, so maybe there are others. It'd be interesting to find out where these rules are defined. We might have a look in the source code, see where it's getting them from. Have a look on the GitHub repo. Alright, so what's it checking for? Name mismatch, pass. This is the thing where in an Arduino project, the main source file, the .ino file, has to be named the same as the directory it's in. And the IDE always complains about that if it's not right. And it says, would you like me to rename or move into a subdirectory, whatever the thing is. So it's checking for that. Prohibited character and file name, that looks okay. File name too long, that's okay. .pde extension. Hang on. Is that looking for something and checking that it doesn't have a .pde extension because it says it's passing? Well, let's come back to that. I want to see some failures, so let's make some things that break. Source folder case, pass. Okay. Arduino.h case, pass. I wonder if that is because no, there's an Arduino.h included in a library. I don't know. No readme, pass. Okay. So I've got a readme in there. Somehow it's detected that I've got a readme. No license file, fail. So it hasn't detected a license file. I think I do have a license file in this directory. And what's it got? Sketch.json, JSON format, skipped, and skipped. Notice no metadata file. Interesting. Alright, so I've got 1 warning, 0 errors, and rules passed are true. And, hang on, I don't have a license file in here. I'm pretty sure I have a license file for this project. Let's see. Yes, okay. It'll be because, yeah, there we go. License. It's because what I've done is structured this project as a directory. In fact, that's kind of interesting. Okay, so Andy said, Arduino Lint blog mentions there are over 175 checks. And, yeah, well, hey Andy. What was I going to do a second ago? That's right, I was going to have a look. No, that's not what I wanted to switch to. That switched to Final Cut Pro, which is running somewhere. Maybe that's why my computer is kind of stuttering at the moment. I'm going to switch back to that. This is a video I've just been editing about to you. So I'm going to quit out of Final Cut Pro. and that might free up some resources. Oh, look, I'm looking very glum in that still standing in the kitchen. Alright, Final Cut Pro can finish closing after a while. It'll take a while. Where was I? That's right, license file. So I'm getting the linter to look for a license file. And what I was just going to show you, this is actually a subject that I think deserves to be a standalone thing, which is how you structure your projects. I don't want to get totally sidetracked into that, but I'm just going to show you this because it's relevant to what this linter is doing at the moment. So I'm going to go into my Superhouse projects directory, and what have we got here? AQS, air quality sensor. Okay, so oh, it's very small, isn't it? It's a bit hard to see. Let's see if we switch to, yeah, doesn't make it much better. Oh well. Alright, so what I've got is a project directory. The way I used to have all my projects was on GitHub, for example, I would have a repo for a PCB, and then I would have a repo for the firmware that runs on that particular board. And then there's the question of where do you store other stuff like enclosure designs. What really pushed me to make this change was when I started doing a lot more 3D design work and designing things like enclosures for the air quality sensor. And then I was thinking, where do I store the design files for that so other people can access them? And I didn't want to end up with 5 or 6 repos for one project. So I've ended up going through a process of consolidating projects. So what I've got here is the AQS project, and if I back up one level, you can see the projects are named after their SKU, so their stock keeping unit. This is just projects that I've been restructuring. So AQS is the air quality sensor. Then I've got a directory for the enclosure, and that has STLs in it. Oh, I've even got G-code in there. I wonder if that's committed. Hopefully not. So there are STLs for anybody else that wants to print that enclosure. There is a firmware directory, and then inside firmware I've got sketches. So I've got the one for the D1 Mini, so the ESP8266, and I've got one for the ESP32. Then there's a hardware directory, and in this I've got, oh, interesting, I've got a couple of different versions there. And you can see there are some temporary files that Eagle has created that haven't been cleaned up. They wouldn't be committed, of course. So Eagle project is in there. I made a duplicate because I was doing a crazy experiment. There's an images directory which has photos of the project and things that people might find useful when they're trying to build it. There's a license directory. So in here I've got the BSD license, which is what I applied to the firmware, and I've got the Tapper open hardware license, which is what I applied to the PCB. Then the production folder, and this is where things go that you might need for producing this thing. And so in this case I've got Simplicity Studio in there. There's a config in there for the CP2102N, which is used as the USB serial converter. There's a README at the top level, so everything else should be inside subdirectories. And there is a resources folder. And I don't know if there's anything in that for this project. Looks like it might be empty. But normally in the resources folder I'll put things like PDFs of data sheets for specific things that are used in that project. So anyway, that then becomes a single repo on GitHub or wherever it happens to be published, and it means that everything is all in one place. So if you want to build that project yourself, you've got access to the source code, the PCB design files, pictures of the project, documentation, and normally there would be another folder in here called docs, but there isn't on this one. So anyway, the point of all of that is that Arduino Lint complained about a lack of a license file. There is one, but it's back up the directory tree. It's not sitting there right next to the firmware. So what I could do is if I go into license, let's just copy this license, and we'll see what it takes to make Arduino Lint think that there is a license. So I'm just going to paste it in here, license.bsd.txt, and let's just run the linter again and see what it says. Warning count, no license file found. It's probably just because my file name is not what it's expecting. So things like readme.txt or readme.md, that's a standard sort of name. So let's change this to license.txt, run it again. Hey, warning count, 0, so it's found the license file. Alright, well that's something that, in this particular case, I wouldn't care about that failing because there is a license file, it's just not sitting there in the directory with the rest of the project. Well, this is looking disappointingly clean. I was expecting to see all sorts of warnings coming up. Andrew suggested just symlink it. Yeah, that's a point. I could just symlink from there. Let's rm license.txt. Let's ln-s, and the target is going to be this. I have to look this up every single time. Symlink from here to here, or is it target and name? I think it's target and name. So let's try license, license BSD, and I'm going to give it the name license.txt. Did that work? Yes, I got it the right way around. Alright, so now we've got a license file there as a symlink, and let's run the linter again. Hey, it passes. So yeah, you're right, that works. Thanks for that suggestion. Okay. Johnny said, okay, do one of Sion's libraries now. No. Oh, Michael said error, and error did not occur. Error count, 0. Okay, now I want to real input, yes. So the way to fix it, the thing is that the way I remember argument order with most things is some kind of a real world analogy. Like if you read it out like just reading English, it's like you could read it as either make a link from here to here, in which case it's the it's the name of the symlink first and then the destination of the symlink, or it could be make a link to this and call it this, and that's the way symlinks work, which is slightly backwards in terms of the way my brain works, which is why I can't quite grasp onto it. Okay, so let's see what we can do in here. I want to see some failures. Let's have a look at. I would be really surprised if I haven't screwed up in some way, and there's something in here that is like a defined variable. Let's just try this. I'm just going to make another thing that we know is not used. So I've declared another variable, haven't used it, run the test, see if it comes up with an error. No errors! That's kind of disappointing. I was hoping it was going to catch that. Alright, I would love to see... Oh, DefPom, you're here. Yes, I did drop in on your live stream earlier. I didn't see the start of it, so I didn't see what you're actually repairing. I saw the thing with the buttons and the PCBs in its enclosure sitting on the bench, and it looked kind of like a very old computer, but I didn't actually know what it was. So, what were you repairing, DefPom? Oh, okay, Datron 1062 6.5 digit multimeter. Cool. It was the thing was large. It looked like a big rack mount box. Interesting. Okay, so where are we at? Okay, so I deliberately broke it and it didn't break. I want to find things that this linter is going to pick up. Can you add your own rules to Arduino Lint? Great. Ooh, Andrew said, what about with compliance is strict? Ah, let's put this back in. And I'm just going to run help again. Let's see what arguments we can pass into here. So compliant string, configure how strict the tool is. Can be strict, specification, permissive. All right, so while we're here, let's look at the output. So we've got format string, output can be formatted as text or JSON. That is really interesting because that means you can integrate it more easily into a continuous integration pipeline. Because what you can do is have some other piece of framework, like you could have a bit of Python or whatever, that calls this tool, gets the result back as JSON, and then you can parse it more easily. If you're running a command line tool and just getting the human readable text back, that can be a real pain to manage because it means you've got to sit there and parse the strings and look for keywords and things. It's pretty horrible. But if it outputs in JSON, that is much more useful. So we've got a help, library manager string, configure the rules for libraries. Alright, I might pass over that just for now. Project type string. So sketch, library, platform, or all. And recursive, search paths recursively. So, okay, so what you could do is get it to lint many projects within, that could be interesting. I'm going to try that in a moment. Get it to run through maybe my entire sketchbook and see what it comes up with. That could be really embarrassing. Report file. Okay, save a report on the rules to file, running verbose mode, we know about that one, and version. So yeah, let's try compliance string. So we'll do compliance strict in the current directory and see what it says. Okay, we still passed everything, even though I've got that thing, that variable declared in the source code that is not being used. All right, okay, no, what I'm going to do first is I'm going to do format JSON so we can get the output coming out. Now this is a clean result because there are no errors as we've just seen, but now we've got this result coming out and it's showing us the path of where it's searching for this thing and how it's been set up, which is useful information if you're parsing this in some kind of a continuous integration tool. So we've got projects. Presumably this is because you could get multiples if we were running this through a directory and then it was recursing through them. Oh, it's got recursive faults there. Interesting. So we've only got one project in here. But if we were running this in a directory with many projects and we were running it recursively, we could probably get multiple entries in here, and then we would get this result for each of those entries. Mark just said in VS Code there are linter plugins that can be used for code linting. Cool. James, push this to Node Red and have it shut the lights off if you make a mistake. Yeah. Alright, so then we've got the summary at the end, pass true, warning count 0, error count 0. So it's the same information that we were just getting. I wonder if it makes any difference if I run this in verbose mode, in JSON output with verbose mode, see if we get the details of all of the tests. Hopefully we do. And we do. That's good. It's what I would have hoped to happen. So it's showing us each of the rules that it's running, the ID of the rule, and pass and the level. So the result, pass or fail, and the level. This is just a notice. So if you had a name mismatch, why is that a notice? I would have thought that would be more than a notice because the IDE will not compile it if it's in a directory that's not the same. Let's force that failure. Let's move air quality center. Yes, I can still type good. Air quality center. I'm just going to rename that file so it is no longer in a directory that is the same name. And we'll go back to, no, I don't want format JSON, we'll just do compliance strict, and we'll see what errors it gives us. Error count 1. Good, so we're seeing an error. Sketch file folder name mismatch. The primary sketch file name must match the folder. Good, it's caught it. Let's rename that back again. And what do we do? Okay, let's go into my sketchbook. This is going to be kinda scary. So these are directories in my sketchbook, and the thing is that many of these are these aren't individual sketches. Most of these actually contain either more directories, and inside that are more sketches, or many sketches. So like if I look inside the Superhouse directory, it's got all of these, and what else have we got? Don't know. Libraries. Alright, let's try. I'm just going to run this and see what happens.